Welcome, everyone. The Well Integrity Technical section of the Society of Petroleum Engineers is pleased to present this webinar about risk assessment methodologies titled AI Applied to RA. My name is Pierre-Edouard Vincent, and together with my fellow WITS officer, Jovan Sojkovski, will be our hosts and moderators today. Please note that this session is being recorded and will be available on demand later. Today's webinar will run for an expected duration of 60 plus maximum 90 minutes, but will not have a hard stop. David Jamieson with SALUS will be giving a 45-minute technical presentation originally, which is an update of a previous webinar we had about 2 years ago. This will be followed by a panel discussion, roughly 30 minutes. Georgi Popov won't be able to make the call today because of traveling difficulties, but Raphael Waxin will be with us in a live interaction Q&A with the audience, both on LinkedIn and YouTube. Feel free to submit questions at any time during the Q&A button at the bottom of your screen. We'll be monitoring the queue and we'll address as many questions as possible. And I will, before I introduce David, I will leave the floor to Jovan, maybe to provide a bit of an update on the WITS, and then I'll introduce David. Jovan, over to you.
Pierre. Thank you, Pierre. Hello, everyone. I just wanted to give a flavor of what we are putting our effort in the SP Well Integrity Technical section. And we are committed to advancing the technological excellence, fostering effective collaboration, and enabling high-quality knowledge exchange across the well integrity community. Looking ahead, our priorities for this year will include a structured program of technical webinars and introducing a new way of communication with our community through the WITS tours, which we already have several of them in the Houston beginning of the year, and development of the well integrity training program. This is in pipeline, still didn't come to the table yet. In addition, SP WITS will host a well integrity workshop in the key regions. This year will be in Houston, 10th and 11th November, and planned one for Abu Dhabi Q4 26, or will be moved in Q1 27. One thing really wanted to highlight that we are also planning in April 2027 the Well Integrity Symposium. Location is unknown at the moment, but stay tuned for the more information which will upcome. We also increase our engagement with regional liaisons and academia by presenting SP Well Integrity Technical section initiatives and strategic objectives to universities, with an emphasis on developing future talent in well integrity. In parallel, preparations are underway to introduce and promote SP WITS during the ATC this year, which will be in Houston in October, reinforcing our visibility and contribution to the SP highest technical events. This is a couple of words from my side. Here we can continue with today's webinar.
Very good. Very good. Thanks, Jovan. So it's now my pleasure to introduce David Jamieson. David is the founder and director of SALUS Technical Limited, a Scottish company at the forefront of process safety and risk management. Since starting SALUS in 2015, he has grown the business from a specialist consultancy into a global provider of safety software, training, and expertise. Today, SALUS delivers the SALUS suite of software tools used by organizations worldwide to strengthen better management and risk assessment, and is pioneering AI co-pilots for process safety that bring regulatory knowledge and assurance into day-to-day operations. Quite exciting. SALUS have developed AI co-pilots supporting well operations to organizations including Repsol, which has now become Neonex Plus, and include now some of the former Total Energy's asset. David, thank you for joining us. The floor is yours.
Excellent. Thank you very much for having me. Very excited to be here. I'll introduce myself and an overview today very shortly, but I just thought I would like to begin with a story to remind us that we've actually all been here before. So you might have seen over last week the Artemis 2 flight around the moon, but that's obviously brought back many memories from when we went back there in 1969, one of humanity's greatest achievements. And it's estimated that over 600 million people watched that live, which was the largest ever TV audience. But behind all of this, there was something far less certain. There was a change in how we operated, exactly like what we're seeing now with AI. So the Apollo missions were actually one of the first times in history that a digital computer was placed right at the center of a safety critical operation. And back then in the 60s, if you asked any test pilot what they thought of computers, they were dead against them, hugely uncomfortable with the ideas of a computer being in the cockpit with them. These were individuals that were used to having full control, full authority over their aircraft, and the idea that a machine could support them or intervene or even override them was seen as something that was quite simply dangerous. So many argued that introducing the computers to a cockpit, certainly a spacecraft, was the wrong idea, and others believed that in a high pressure situation, a machine would fail in ways that a human never could. But despite this, NASA pushed forward and the Apollo guidance computer was installed. That's a system that's it's got less computing power than a modern calculator, yet that was responsible for navigation, guidance, and control. And it was a really small, terrible interface that you can look online just to see what that was like. But the astronauts Neil Armstrong and Buzz Aldrin had to trust that that machine would do its job, even though they couldn't see fully what it was doing internally. And at the same time, pictured here, we had an MIT team led by Margaret Hamilton that was responsible for writing software. It was a brand new word. If you look at any of the contract documents sent out by NASA, you'll see that the word software didn't appear in once. They literally invented the word. Certainly software engineering, software was seen as something that wasn't engineering, and it wasn't taken seriously at all. But Apollo changed that. And for those that know their stuff about Apollo, they'll know that the final descent took around 13 minutes, and that was a window in which absolutely everything had to work. And then there started to be a series of alarms, a 1202, then a 1201. There was thousands of alarms. No one had any idea what these were. So back in mission control, everyone was scrambling to interpret that signal, and a young guidance officer made the call. He managed to find out what this was. And actually, there wasn't a failure. It was the computer, overloaded computer, prioritizing. It was dropping non-essential tasks so it could focus on the moon landing. And we all know what happened next. The call was said that it was fine. Armstrong continued the descent. He had to avoid a boulder field, and he landed with just enough fuel to get them home. So the real story isn't that the technology worked. It's that people had to learn how to work with it. And if I go back to what I said, early test pilots, just like a lot of people today, they feared that computers would replace them. But in reality, the opposite happened. The new technology freed up further advances, and their role became even more critical. And the pilots were right at the heart of everything. So just to go back to 1969, we take so many things for granted that were brand new then. Fly-by-wire control systems, real-time onboard monitoring of complex machines, human-machine interfaces, and finally software being treated as something that was safety critical. At one time, highly controversial, and now it's completely normal. So that's the lesson for us today, that new technology, especially new technology in safety critical environments, is almost always met with resistance. It feels like we're giving up some controls. It feels like a lot more can go wrong, but actually when it's designed well and when it's used by people that understand the risk and understand how to use it, it doesn't remove human expertise. It simply changes what we do. And that's why we're talking about AI in this context. We're not replacing engineering judgment. It's something that can support engineering judgment. So just like the Apollo computer, it can raise signals, highlight risks, sometimes behave or tell you things that aren't immediate obvious, but the goal is not that we blindly trust these tools, but it's not that we completely reject them either. So, I believe that preventing major accidents isn't about removing people from the loop. It's about giving our people better tools to make decisions. And just finally, the technology will improve, but the question is whether we're all going to improve with it. And we faced many of the challenges, which I'll go into about rolling out some of these products, and I'll show you exactly what happened. So yeah, let's jump in and let's get started. So overview of today. I'll introduce myself, go through how AI can help you, some really key pieces of governance that you need to know as well, some examples of where AI is being used, not by SALUS, elsewhere in well integrity, and then we'll go through the case study of what we made and some of the challenges that we've faced, and then I'll close out with a roadmap. So my name is David Jamieson. There's my picture there. You can see me. So as you can see there, a process safety engineer, but a significant portion of that time has been spent in well operations and in well integrity. I was originally an aerodynamics engineer, computational fluid dynamics. Then I started to model fires and explosions, and that eventually led into the prevention of major accidents. SALUS is named after the Roman goddess of safety and well-being. We're process safety specialists, and we're really trying to push process safety forward. We've got several business units, as discussed. We've got the SALUS co-pilots, where we use AI to support our engineers in preventing major accidents. We've also got instant investigation and bow-tie software, on-demand training, and a consultancy that focuses on HAZOPs and safety cases. But the thread that runs through everything that we do is we're trying to use new technology, new methodologies to push process safety forward and never accepting the status quo. And just to give you an example of some of the AI experience that we have, we've done quite a lot of work, and I'll explain where that fits in the overall pipeline shortly. We've built something we think of tremendous quality for Repsol, obviously now Neonex Plus, that quality checks their impaired wells risk assessments. It's now mandatory for use in their company, but we've done other similar work reviewing operational risk assessment, identifying cumulative risk across hundreds of open actions and backlog, a forensic analysis of past incident data, building chat interfaces so you can talk to your data. For example, we did one with the HSE and OUK on their hydrocarbon release database, and we also use AI as a core of our consultancy. So let's jump into a few things. So you may or may not have heard of this chemical engineer, Trevor Klett, but there's this really famous quote, part of which that I've got up there, which is organizations have no memory, only people have memory. And once they leave the plant or the asset, the accident is forgotten. So it's quite a sobering thought, and it's 100% true. I'm sure everyone on the call's got experience of the fact that it's individuals that remember these things, not organizations, and we make the same mistakes over and over again. But as much as this statement is true, and as much as I have admiration for the person that said it, I do believe that this is the first time in history that we actually have the technology that can change this, and we can make this quote redundant, and that organizations can start to remember. And that relates both to well operations, drilling operations, and process safety across the board. So I'd like to give you my first bit of guidance about AI. I speak to lots of people about how AI can be used in our industry. And one of the key points is that not everyone talks about the same thing. Sometimes I might be talking about AI when I simply mean a minor chatbot, whereas someone assumes I'm talking about an automated system or an autonomous agent that's going to do everything for them. And each of these uses of AI is fundamentally different, and they've got very different implications. So I want to I've put this simple framework together, and I think it's worth just spending a few minutes on this before we go any further. So number one, conversational assistant, things like ChatGPT style tools. You ask a question, you get an answer, you ask it to do something, it'll do it, but all within that app. Low friction, really useful for lots of applications, exploring ideas, second opinion, or completing simple tasks. But unless it connects to something real, it can't really do anything. You can certainly overtrust its content. I'm sure, obviously, lots of people have got experiences of using ChatGPT. So this is where most people on planet Earth currently interact with AI. They use the ChatGPT app, and that is all. The second is a co-pilot. It's the next step. So that's AI embedded into how you work. That might help you complete a task without leaving your workflow. GitHub Copilot for developers, Microsoft Copilot, for example. And this model applies equally to engineering and safety workflows. The third is a reviewer or a checker. You do your work as normal, and then AI performs a quality check on it, and it gives you pointers for how to improve. This for me is one of the most underrated applications in our industry, and there's so much potential value, and it is fantastic. But I think as a result of that, people forget that actually way back at number 2 and 3, there's a lot of value that can be added. So with number 3, the reviewer, the human still does the work. All the AI does is provide a structured check against defined criteria. Obviously, only as good as the rules that you give it, and certainly it can miss context. But built properly and used well, that's an extra layer of consistency that's very difficult to achieve manually at scale. The fourth one there, monitoring, or specifically active monitoring, that's AI that's always on, watching for anomalies. So in our case, could be pressure trends, barrier health indicators, early signs of failures, and again, a scale and consistency that a person might not be able to do on their own. Clearly, risks, false positives, alarm fatigue, but this is where AI becomes a genuine operational tool rather than advisory. The fifth one, predictive forecasting, using historical data or current data, to predict when the next failure might occur, for example. This has been around for a very long time, actually, in various forms. You've probably heard of machine learning and big data and things like that. Again, hugely powerful, but it is also frequently oversold. If your data quality or availability isn't there, this category, in my opinion, can collapse quite quickly. And many organizations, certainly that I've worked with, simply don't have the data infrastructure to report that. And the final one, autonomous agents. This is AI acting on your behalf, raising work orders, implementing controls, initiating responses. This is the single most hyped category in AI right now, and also, in my view, the most dangerous in a safety-critical context. It's very hard to validate sometimes, and the consequence of something acting incorrectly could be a major accident, a major well incident. That's very significant. So I'd certainly treat any vendor claiming mature agentic AI for well integrity with considerable skepticism. So to summarize, if AI is thinking with you, that's a chat. If it's working with you, that's a co-pilot. If it's checking your work, that's a reviewer. If it's watching for you, that's monitoring. If it's predicting for you, that's forecasting. And if it's acting for you, that's an agent. So whenever you're evaluating an AI solution, whenever you're talking about AI, you should ask yourself, where on this scale does it actually sit? And for example, most of what we've built, or certainly that's in use right now, sits in number 2 and number 3. And haven't really moved into 4 and 5, and we're deliberately cautious about 6, although we are having a look at a few things there. So again, I'd just like to touch on some governance. This might be dull to some people, but it's hugely critical. So how many people know if any AI tools that are in use in their company can demonstrate compliance with the EU AI Act? And even if you're not operating in Europe, you actually might be exposed right now. And this is something that I see constantly, and it's why governance is one of the first things that I want to address today. And the key message is simple: know your governance when it comes to using AI. It's not just as simple as creating a new AI app, doing a little bit of testing, and off you go. Depending on where you operate, how you operate, what you're using this product for, there are quite a lot of key pieces of governance that you need to make sure that you're following, because there is quite severe consequences for not doing so. So let's take the UK HSE as our first example. They've taken a deliberately minimalist approach to AI. So their position is quite clear. All existing regulations continue to apply, and it's your responsibility to demonstrate compliance, whether you use AI to meet them or not. So the implication I take from all of their work is, well, even if AI produces the right answer, if it's a black box and no one can explain how you got there, then that won't satisfy any regulator here in the UK. But the bigger one for me is the EU AI Act. And why I bring this up is because I think this will be the eventual direction a lot of territories will move in. So that says that using AI in what they deem a high-risk area, there's heavy governance, documentation, and assurance requirements that apply. So for high risk, what they mean is it's something that's used for critical infrastructure, safety, components, management of worker safety, or something that could materially influence life or death. So it's very likely that the use of AI for anything to do with well integrity or any risk assessment around any well operation would absolutely meet that definition. So if you do meet that definition, what does that require? So now you might recognize some of these terms, but what it means is you need a risk management system for how you're using AI in this application, documented governance on the data that's going into it, technical documentation for how it works, demonstration that you've got appropriate human oversight, ongoing assurance of its accuracy, robustness, cybersecurity, and something that they call post-market monitoring, which is basically plan, do, check, act loop. That means that you're continually assessing the performance and improving it over time, not just on day one. So there's quite a lot to unpack there, but it's worth just saying there's quite a lot of additional information that comes with it, though. This isn't guidance that needs to be followed, and you'll get a letter if you don't comply. It's legally enforceable, fines of up to 7% of a company's global annual turnover for serious breaches. Now, it's not fully phased in. It's been phased in gradually over the next few years, but it does have extra territorial scope. So if you're not based in the EU, but your organization in some way operates with the EU, that still applies. So this is a very clear and very strong direction here, but really the key takeaway for me, well, there's a few key takeaways, and that's that this feels very heavy compared to lots of other territories. For example, it's the opposite of the US. But history tells us that after we have a significant incident, so after we have something that involves inappropriate use of AI, we expect some reactive regulations to be brought in. So my key takeaway here would be understand your governance obligations, both internally about IT access, cybersecurity, data handling, and also from a regulatory standpoint. So some questions to ask yourself if you are using AI. Does this influence major accidents or the potential for a major well incident or a well operation? Is this making operational decisions, or is it just inputting to them? Have you documented its performance? Can you measure its performance? Can you validate its accuracy? Could it be overridden by humans? Is it clear of what its limitations are, i.e. when not to use it? Could it be misused, used outside its intended scope? And who and how is who's monitoring performance and how are they doing so? And who specifically owns the risk? So my final advice on this is if AI in any way touches major accident risk, major well incident risk, process safety risk, well integrity risk, you've got to treat that like any other safety critical system. So that means documenting it as you would a safety case or a performance standard or any other key document like that, and have some way of monitoring its performance in the exact same way as you'd monitor any well integrity barrier, and never allow it to operate without clear human accountability. So that's the background on the regulations and where we are. Let's talk about what's actually happening right now. I spent quite a lot of time looking at what's happening in the well integrity space with AI, and there's quite a lot of things here. I feel there's a big tendency to drift quite quickly from either hype to skepticism and not a lot in between. So you'll hear lots of people say things like AI is going to transform everything. It's going to predict failures before they happen. It's going to fundamentally change how we operate wells. But then on the other side, you'll hear people say that the data is not good enough. Systems are too complicated and this is all a bit overblown. And to be honest, the reality from what I see sits somewhere in between both of these. So what I want to do is just ground this in what's actually been done so far in the industry. Particularly, there's some SPE research papers that I want to talk about, and that'll give us a view on where we actually are. So I think it's just worth reminding ourselves what we're dealing with. Sorry if my slides work. Yeah. So obviously well integrity is not something that just gets solved at one point of time. As you'll all know more than me, it's not just design, it's not just drilling, it's not just ongoing operation. It's something that has to be managed across the full life cycle of a well, design, construction, production, interventions, right the way through to the late life and safe abandonment. And literature obviously backs that up, and reviews of various well integrity management systems. Those things consistently make the point that integrity has to be maintained across all phases. What is also important is that these failures are rarely caused by a single event. Almost every single well incident that's taken place has been the failure of more than one barrier, one safety control, and the other one is that those controls were likely weakened long before the event. They just weren't being picked up. So straight away, you're dealing with a really complex problem, likely developing over long term, quite fragmented in terms of data and ownership. And that really matters when we talk about AI, because it means it's not really a clean problem with a single data set and a single answer. So people in the well integrity space have been really busy on the AI front. There's quite a few good examples of AI being used in well integrity, but they do tend to sit in really specific areas. So some of you might be familiar with these examples already, but there's a fairly consistent pattern that I'm seeing. So I want to go through 3 of them. So the first one, detecting integrity issues from time series data. So this is from an SPE paper where AI has been used to detect annulus leaks. So the approach was they took time series data, just lots of data gathered over time, things like pressure and temperature, and they trained models to identify patterns, to identify something's not right. And the results were hugely promising. So about 3/4 of the historical leakage events were detected. There was incredibly low false positives, less than 1 false positive per month, so a really solid result. But the important detail here is that the data set was very limited. There was only 12 historical leakages over a 13-year period. So what you're seeing is AI working well, but in a really specific context on a clearly defined problem with a known signal and a really small number of failure cases. So it's a great example, but not a universal, or there's certainly not enough data with that work to say that that's a universal solution. So to put that into well engineering terms, that approach shows that it does well at detecting that sustained casing pressure developing into a B annulus before it reaches an operator's threshold, but it can't tell you whether you're looking at a tubing leak or a failed packer or a compromised cement job. So that interpretation still requires a well engineer who understands that barrier philosophy. So promising there. There's another one for AI for defect detection that looked at corrosion detection specifically. So in this case, the AI was interpreting inspection data, and then it was inferring things like the depth and any defects in the casing. Again, really, really interesting, and it's exactly the type of area we'd expect AI to do well. You've got structured data, measurable output, and you've got a repeatable, time-consuming, tedious task where consistency matters. And again, it was great. It showed it could more consistently pick up these potential things that were harder to spot manually. But a few important things to consider. The AI is not deciding whether the well's safe. It's not making a holistic judgment. That's simply helping extract info from inspection data and have that used and presented more effectively. So again, for a well engineer, that means that you're getting that information a lot faster, a lot more consistently, and it gives you more time and more data on which to make decisions, particularly if you've got dozens of wells in your late life portfolio. So there's an example of AI accelerating that data reviewing, analyzing process, but the fitness for purpose decision still rests with a well engineer. And then the final one, this was also really interesting, machine learning for prediction failure. So there was a machine learning model that was developed and that analyzed and that diagnosed well integrity failures in artificial lift systems. So this was a bit different. It had more data, 9,000 data records, and it showed that various models performed well and they had extremely high accuracy. Sounds really impressive on the surface, but again, looking at the context, it was quite a defined data set, one specific area of the system, a single operator, I think. So there was defined sort of set inputs and outputs. So it's not quite the same as predicting rare, complicated failures across different wells, different operators, different conditions, different countries. But again, very, very useful there. So again, another great candidate. But to move to something like predicting when a wellhead valve will fail to isolate or when a cemented annulus will develop communication, that data becomes far more sparse, far less structured, and the failure model is a lot more varied. So overall takeaway, lots of promising work. These were really exciting papers to read. I suggest that you go and read them. But again, there's limitations. So AI does work in some areas and it does struggle in other areas. And I've certainly seen that. So clearly, where there's a clearly defined problem that's supported by structured data and is essentially just recognizing patterns, it does incredibly well. Anomaly detection, inspection data, interpretation, classification within known data sets. That's all brilliant, all makes perfect sense, because that's core. That's what these models do. They just find patterns in data. But where AI struggles, and this is, again, where you see a lot of the non-positive feedback, is when you move away from that. And one of the biggest challenges is simply the input data. Well integrity failures, particularly the serious ones, are rare. Obviously great from a safety perspective, but it means that you don't have large volumes of failure data to train model in. Another challenge is generalization. A model works well in one asset, one place, doesn't actually transfer well to another. Different well designs, different operating practices, different data quality. So all of that really affects how well a model performed. That penultimate one, context and judgment. I do think this is a problem that's becoming less and less, but the decisions aren't made on data alone. They involve interpretation, experience, and an understanding. So you always need a human in the loop. And then finally, trust and explainability. So in a safety critical environment, it simply isn't enough just to produce an answer. People need to understand how that answer has been produced, why that answer has been produced. So there's a bit, when you look at the industry view overall, particularly through some of the SPE publications, it does seem that there's quite a balanced conclusion. People recognize that AI can absolutely improve consistency, can absolutely speed things up, and can absolutely help with large volumes of data. But there's a clear message that we still need to have engineering judgment and certainly not replace that. And I absolutely agree with that. Maybe just some final words on this before we move on. I think if you look at what's missing, that's where things get quite interesting. Most examples we've talked about are focusing on detecting issues, detecting anomalies, defects, patterns in historical data. So they're looking at what's happening in the system. But as I said earlier in that slide with that scale, I think less attention's been given to other things, such as the quality of work being done by engineers themselves or quality of risk assessments. Because if you look honestly across the industry, I think there's lots of consistent issues. You see inconsistencies for like how risks are assessed, how barriers are identified, the logic behind the decisions that are made. And so these aren't really problems that appear in censored data. These are things that exist in an office, done way earlier. How we think about risk, how we document risk. So, think about what that looks like in real life. You might have an operator with a few engineers that are looking after several hundreds wells with active impairments. They could have like sustained, casing pressure on the annulus, have a failed downhole safety valve, another wellhead valve that won't fully isolate. So each one will have an individual risk assessment sitting behind it. But how do you get consistency and maintain quality across all of those risk assessments in our portfolio? And certainly in the UK, when you look at output from the UK regulator, the answer would be, well, not very much. So one engineer might have identified the correct compensatory control measures and scheduled a repair, but another might have documented it but had a vague forward plan. And a third might have an assessment that was written 18 months ago and nobody's ever reviewed or updated as the situation's changed. So the sensor data might look fine, but the integrity management system shows green, but the quality of the risk thinking underneath that might be highly variable. And that's something that might be invisible to quite a lot of these tools. So as I say, I personally take quite a lot of interest when I look at things that not a lot of other people are looking at. So there's lots of fantastic work going on with the agentic AI, lots of fantastic work going on with ongoing monitoring of all of this data about the live diagnostics, but is there less attention being paid to actually reviewing the engineering work that we're doing and the quality of risk assessment? So let's go through to what we've made then. So just to tell you the story of any impaired safety critical element, safety control, well integrity barrier, however you want to describe it. This applies across the industry as a whole, but obviously we're looking at well integrity here. So you have and again, sorry, this could be a failed downhole safety valve, a pressure building up, an annulus that can't hold its pressure, anything like that. A wellhead component showing signs of corrosion or leakage, lots of things. So these aren't catastrophic failures on their own. The question every time I deal with these are, what is the actual risk? What other controls do we put in place? Is it safe to continue operating? So what you have a period on the bottom left here of just a sustained period of risk. That's your normal risk of operating. And you then have that safety critical impairment. And there's a likely period of time that you might have been operating with that and not known. But once you know that you've got that, everyone would agree that the risk then goes up. So then there's a period of time, and hopefully a very short one, where the risk's massively elevated, but you're deciding what the correct course of action is to take. You might shut in the well, stop the operation, depending on what you're doing. Or you might decide that you want to introduce some additional measures, often procedural controls that will replace the defected engineering control. You might want to do increased monitoring of the well, or operate at slightly lower conditions. So you'll implement those controls, and then your risk will go down, and it will go down for the period until you've fixed the problem. So hopefully you're able to get that as low as possible, and then return to normal operation as quickly as possible. So any impairment to a safety control should, like any story, have a beginning and an ending. It should be temporary. If an impairment does have no end date and no plan for resolution, then that would be a management of change that you should be having there. So the key point here, and this is what we'll look at with our example in a moment, is we want to reduce the duration of exposure, but we also want to keep that residual risk as low as we can. So Repsol came to us in 2023 with a problem. This was their well risk assessment management workflow. Their big problem was the volume of wells that they had, the age of the asset base, the variability across teams, and the administrative burden of all these risk assessments are obviously becoming a problem. So they felt that they would be able to manage that risk in a slightly different way, and then that might have a lot of different results. And you can see here that the impairment's identified. There's usually an initial call made. There's then a risk assessment team assembled who performs what's called a WRA, and that's the heart of what we look at. That's then subject to review and approval from the senior members of the team, but often there was feedback, more was asked for, more information, more action required. So that loop could go a few times. You would then monitor and assess that for the duration of the impairment. And again, if something changed, then you would go back and redo the risk assessment. And then you would eventually close the WRA. And again, we're talking abnormal pressure readings, failed instruments, failed valves, you name it. That's what they are. And but what's very difficult is there's a tremendous amount of governance to follow, a tremendous amount of things to be decided, loads of UK offshore laws and regulations, thousands and thousands of pages of guidance from the likes of Offshore Energies UK, and their suite of well integrity documentation and ISO standards, etc. So what we did was we took all of the feedback that they'd received internally from the regulator. We trawled the database of all the regulator enforcement, regulator action taken. We went through all of the governance documents, and we have jumped about a bit, but yeah, sorry. And I think there was something like almost 200 individual checks that we do, and some of these were very straightforward, and some of these were obviously really complicated. So let me just jump forward one. So I'll bring up a live demo. So what we did, there was 3 different areas of what we do. So the team would perform their WRA as they normally would, humans doing the work, and we would check 3 different parts. Is all the required information present? The next one was a quality check of the risk assessment itself. And then the third was a quality check of the forward plan, as in what's been planned to manage and close this out. So it does sound very straightforward overall. And again, I want to get that across that if you go back to that scale, this is at the review stage. There's no agentic, there's no live monitoring. And yeah, just to give you a sense of what that looks like in practice, one of the first risk assessments that we checked, clearly I missed a simple thing, that there was no work order actually raised to fix the impairment. So again, that was a well had been running in a degraded state, and there was actually no work planned to have that closed. So that was great. So what's happened since is that that's been made mandatory across the organisation, and the feedback has been that quality and consistency's gone up, and we can see that in the data ourselves. What our tool is suggesting is becoming less and less overall. So it's sort of finding fewer things. So that for me, it's evidence of that. So let me bring this across now. So obviously this is all just fake user data. So there's nothing here that's proprietary at all. This is all fake. And that's a member of my team. So you would have a well impairment that was put in place. You'd enter all your information here. As I say, this is all completely fake. And you would summarize the impairment, and there'd be quite a lot of things there. You'd put the history in, and people would have to trawl lots of data. I've made this very simple, but this is all the impairments that the well has, and then you might add additional information here. I've already run this in advance. It takes about 90 seconds to run, so I don't think anyone wants to watch the screen go here. So this is stage number 1, that input audit. So what this does is there's various criteria here. We summarize what we think that we've understood, and that's a great way for the team just to make sure that it has captured. And then these questions to answer, rather than simply saying you've missed a bit here, we don't think this is very good. We agreed on asking open questions, the answer to which would close a gap. So let's even go through here. There's a requirement from OUK internal that you have to be very clear about some of the other risks. Is there potential for the well to outflow? Is there other well integrity issues? What is the well sort of flowing rates? Could it sustain flow, etc.? And if I just maybe choose one more as well, about any additional redundant systems, for example, or there are some quite clear things of what the team should do. So what happens here is the team can then answer some of these questions by including the information up there. Then they run this again. There's fewer questions, and then they get to a point, and this one's given a tick here, where although there's some gaps to be filled, we felt that enough was there, and that allows them to move on to the next step. So if I just go back, that's number 1. So have they included all of the required information? So that's that. And then number 2 is the quality check of the risk assessment. Again, I'll not analyze this one. This takes a few minutes as well. So what this does is, from the information provided, it looks through all of their governance, and it says, well, we think that these are the anomalies that have been identified here. And very often what we get back is the people never realized that a particular set of circumstances was an anomaly. So each one of these then needs individually risk assessed. And then this doesn't look very well because I've zoomed in a bit, but then that's a risk assessment that can be edited. And this is pre-populated by AI, but they have to, human beings have to actually go through and do this. And this is, again, based on what should be in place. And typically what we see is that the controls and mitigating actions are things that might not be able to be done. So people are then able to go and make sure that they put the correct things in place. So this to me doesn't look great on this screen here, but you'll see a lot of this is blank because people have to go and then fill that in. So that deals with number 2. So is the quality there. But then the main one for me is that forward plan. I was very clear that risk assessment needs to have a beginning and an end. So if I scroll up here, I think at this one, I've just written a very bad forward plan. We're planning to fix this in the next few months. Obviously, that wouldn't surprise you. That doesn't quite cut it. So there'll be quite a lot of information here. There's not really an LARP demonstration here. It doesn't really discuss the resources required for the forward plan, engaging of key stakeholders, about all mitigating actions, having an owner, etc. So the idea is that you would run this to a point where you didn't get any questions. And you could say, well, we've demonstrated our LARP, our forward plan is robust. All the required information has been shared with everybody, and all the timings and owners and things like that are all there. And that makes it really easy for someone to check this as well. Imagine that you're a manager in a well department and you've got lots of these things to check. Well, it's great that you could go in and see, well, what's the AI picked up. You still do the check, your team have still done the risk assessment, but you've got this extra layer of protection here where that we can do it. And just to give you a look of what's going on behind the scenes, this doesn't look as pretty, but this isn't just stacks and stacks of code and scripts and files that if, it's just only in one person's head. Again, this is just a demo version, but this is our system that we've made. It's all drag and drop. It's blocked. All of the green stuff is input data. So that's come from the page that you just saw. All the orange stuff is looking up data, and the purple stuff is AI doing things. And then that's data being put together, and then it's something being fed back. So our engineers perform weekly or monthly audits on all of this to make sure that the accuracy is still there. We can measure that performance. And at any point, if someone chose to come and audit, then we would be able to demonstrate how that all works. And I think just maybe a couple of final sort of points from me is, I think a lot of people do webinars like this and tell you how great everything was, but there was a lot of key learnings that we had and improvements that we had to make, and I think a lot of people might run into these as well. So I thought I'd share some of these with you if you're planning on implementing any of your own solutions. So the first was time. Usually, as an engineer, you're writing a report or doing some analysis or calculations. You've got a fair idea of when you think you're almost finished. And what we found with this is, we'd done a pilot. It was a working demo, worked really well. And we estimated it would take a further 6 weeks for us to complete this. But it actually took 4 months. And fortunately, we're in a great position. And obviously, the client was hugely supportive, and the quality that we ended up with was excellent. But certainly with dealing with AI, particularly with well integrity, because as it is so complex and it has to be 100% accurate, is that you absolutely, it's so hard to estimate getting to that final hurdle. So we found that final 20%, that final 10% would take 80, 90% of the entire time. So I'd absolutely say that your estimates for getting something production ready as accurate as it needs to be, I'd be hugely conservative with that. The second was data quality. It's almost cliche to say that AI is only as good as the data, but it is something that's absolutely clear. So I would really robustly test all the data that you can have before you jump in with 2 feet. So for example, one area that we were going to do is have a separate module that looked at all the past risk assessments and took the most relevant ones and gave you pointers based on that. But really the quality of those, they were just so inconsistent that actually there was no basis for us to actually reliably provide value with those. And looking back, that's something that was potentially entirely predictable. So really look at what is the input data that you require. Is it available? Is it of the quality that you need? Can it be read by your system? We hear of a lot of AI projects that come undone for that. And then the third is perception. I believe strongly that these tools supercharge your engineers. It can get rid of repetitive, tedious, time-consuming tasks and free you up to do more engineering, do more thinking. But I know that not everyone does feel like that, and I think you can get a lot of pushback with these systems. It was like when I first started to work in decommissioning or well abandonment projects, the operations team knew that you were working on the end of their assets. So you saw some resistance there. So I think that's something absolutely that like we see here. And we had some negative feedback to begin with, people saying it was being too pedantic, asking for far too much, and we sort of checked it all, and the system was doing exactly what it was designed to do. It was just enforcing standards that hadn't previously been enforced. But certainly there was a lesson for us about tone, about if you've got a very bad WRA and a very good WRA, giving some slight pointers to the good ORA has to be done in a certain way so it doesn't look pedantic. And equally, if you've got an incredibly poor ORA, there's no point giving that minor pointer feedback. You should focus on the fundamentals. So for us, how we deliver feedback certainly was something that we had to give a lot of consideration to. So these are absolutely things I'd want anyone embarking on a similar project to know. And if you are doing something, whether it's internally or with another company, I'd gladly sit with anyone and share our experience, because there's a lot of things that you can make life a lot easier on yourself. So the sort of final takeaway bit for me is, we've looked at examples of AI in action. Obviously, I've talked about some issues that we've had, and I know that we'll go into these further in the panel session. So you might say, well, what's the right way to adopt AI in well integrity and any other safety critical industry? And most of the issues don't really come from the tech. They become like from how it's adopted, whether your project's poorly scoped, you don't have all the stakeholders on board, or there's gaps in the data, etc. And we've seen that directly on stuff we've worked with. We've heard about it with other people as well, and we've actually worked with a few people to help them come up with their own AI strategy. So I'd say you can't deploy AI in our industry, our applications, without a sort of structured people first approach. So again, try to summarize these things into workflows. Here's 7 main steps. There might be a few more, but I'd certainly say number one, clearly define objectives and stakeholders, and that's just getting people aligned. Do this before you touch any tech, and that's make sure whether it's ops, HSE, IT, cybersecurity, your leadership, make sure that everyone who needs to be on board has bought in. This is not an isolated project. It does need IT, but it's also, some companies try and manage it like an IT project that touches everyone. So absolutely get all of your stakeholders mapped and get them on board. What do you actually want the AI to do? Is it to reduce time? Is it to improve consistency? Etc. Set really smart objectives so that could turn your ambition into something that's trackable. Number 2, assess your readiness, evaluate your own technical infrastructure. How ready is your organization? You can't build these things on shaky ground. I've learned that, unfortunately, the hard way. You need to assess whether your existing infrastructure, data, storage, compute power, how you integrate into your systems, all of that sort of thing. Do you have the right things in place? Are you ready for this? We worked with a client whose management system wouldn't let you export action status, so they couldn't determine whether actions had been closed or not. It was a simple thing, and it wasn't picked up until the project had already kicked off, so there had to be a change. So really make sure. The next one really is about structure and prepare your data. It is true that AI is only as good as the data behind it. Most of the work happens on your data, and many projects sort of fail here. So again, map all of your data sources, make sure that you can access them, make sure that the quality is actually there within those data sets. Can you clean it up in the way that you need to? Really working with incredibly small pilot test cases here, something that works very well. Fail as quickly as you can. And if you then select your tech, the right tool for the job, whether it's large language models, other predictive models like that. These do have an impact. Can the tech stack be built in such a way that it can interpret all this technical language, analyze all these documents? Not every model fits for here. So again, I would again run small pilots. Make your call evidence-based. Don't rely on a company's marketing. Data security, hugely important. There's incredibly sensitive operational data. Security, if that's non-negotiable. So all of this stuff, it's slightly over my pay grade, but certainly that's a huge part in any system that we build, in any customers that we work with. If your AI can't meet the same security standards as your existing safety systems, then I don't think it should be used. And then that number 6 is just rapidly prototype. Start as small as you can, fail safely, learn quickly. I would always say to everyone, don't try and do everything at once. Pick a narrow, high impact use case, build that prototype, and then grow from there. And then the final one, if you remember back, we talked about the EU AI Act and all of that Plan, Do, Check Act. You have to have something in place to govern this, monitor this, and adapt and update it as need be. And likely you'd have that before you go live. So establish who's got authority, who's in charge of it, who documents it, who agrees these rules. How do you audit this safety critical system? Because that's what it actually is. Track its outputs, monitor it for drift as you would any pressure sensor. AI used in our industry is absolutely not set and forget. It requires active monitoring, active stewardship. So then the final thing for me, so lots of ground covered there. I can see there's a few questions coming in, which is fantastic. There's loads of areas where AI is genuinely working well in well integrity, like today, but there's certainly areas where we've seen where it's struggling or not been proven at scale. I've shown you what good governance looks like, some challenges that we've had. So if there's anything I've said today that's relevant to your operation, if you've got a specific well integrity challenge or risk assessment process, always happy to give anyone any guidance for any projects that they want to try. The last thing I want is for you guys to suffer the same things that I have. So my LinkedIn and my email are on the screen there, and I'll respond to everything personally, and just happy to help and support anyone that's trying to move this stuff forward. So yeah, that's absolutely everything from me. So thank you very much for listening. I think I've kept to time, and I'll hand back to the team.
No, fantastic. Thank you, David. So I really enjoyed your presentation, and to be honest, it absolutely resonates. So a great job at an impactful presentation for me. We had a couple of questions, and so maybe we'll take some of those after we've had maybe a bit of a reaction from other panel members. Jovan or Rafael, do you want to, I don't know, give your immediate reaction to what David just presented?
Sorry, I just unmute myself. Yeah, really interesting presentation, David. Thank you for sharing with our community. Really, I'm fan of the AI and all what can do for us, what can help us in shaping our risk assessment and having a better decision. So fully support on development, and great job from your David and your company.
Rafael, any comments before we start a few questions?
Yes, of course. I'm really impressed by the presentation, and thank you so much, David, for all this work, for the ability to share not only the glittering and appealing part, but also the doubts, the prerequisites, and not only the possibility to fail technically, but also to fail for other reasons, such as the explainability of models, the trust, and sometimes very high expectations that get disappointed for more trivial reasons than we believe. So it's really enlightening to see a reasonable voice and honest voice about what AI can do or not.
Very good. So we'll take an easy question first from Edgar Volmar. Is it possible to get a copy of the slides? so if you're happy to share, either write to David and he'll share with you, or if you're happy to post a PDF version on LinkedIn, I can do that also. All right, then a question from Dharmesh Mehta. It's good to have AI for RA. However, it may not help to assess actual field conditions or SIMOPS in the field. How do you potentially overcome such challenges?
Really good point. So again, a lot of that, if you go back to that roadmap that I talked about, is about really defining what that project is, what its limitations are, and where AI is actually being used. So you're absolutely right. That application that we've got doesn't help with actual field conditions. For me, that would then be a separate tool. And obviously there's lots of those, but even without AI, that's something that I think as an industry that we already struggle with, is bringing together all of the different pieces of information that you've got. And a lot of people have tried various things like dashboards and all of that sort of stuff. So absolutely. So for me, it's all about eliminating risk where we can. What we've built is very separate from looking at things like SIMOPS in the field. It's just worth touching on, though, something that our tool also does that I didn't want to go too much into, but it also looks, or has the ability to look at, other risk assessments and that cumulative risk as well. So you do start to get things that I know of lots of people updating like permit systems and things like that are really starting to look at SIMOPS risk. So there's hugely exciting there. But again, that's more, I don't know if you can bring my slide back up, but looking at active SIMOPS conditions in the field, that's like number 4. That's the next thing. Whereas what I showed today was looking at, number 3, the reviewer. But yeah, hugely challenging. Yeah.
Yep, and I would agree to that. And as you mentioned, there's the notion of aggregated risk on top of simultaneous operations also, which systems don't necessarily display very well today. So it's a bit of a shortcoming. Question from Uchenna. Data sources, some examples.
Yeah, I did have a slide, ended up looking a bit busy, so I took it out. So yeah, so what are the sources? So certainly, let's just take some of the guidance that's out there. So we've taken industry guidance, so things like the OUK well integrity guidance or their internal governance. And basically what we do is we convert a document like that into a list of requirements. And then all of the well integrity risk assessment data is aggregated, and then we have individual tasks that are performed where we're like, in the data that we've got, is there evidence that this requirement has been met? Yes or no? And then we've got a separate tool that then sort of checks that that's been done, and then a separate tool that then takes all of that and decides the appropriate way to give feedback, as I said earlier. So that's a mixture of regulations, guidance, safety alerts from the regulator. You can, the like UK regulator, for example, it's got all of its enforcement action that's in the public domain. So we look at that. We've also managed to get access to some information that's not in the public domain. So we've looked at where other people have had failures and had incidents. And what we don't have here, but we do have in other applications, is that looks at past incident databases as well. So that's something that we're very clear. This is all the places that it's looking at. We assess for each individual requirement, or if there's an incident, we make sure that all the causes of that incident are covered as controls in this risk assessment. So lots of different data sources. But if I just talk on one of the points that I raised about the ongoing accuracy, so that means that we need to go back and update our glossaries when these documents get updated. There's quite a glacial pace of guidance being updated. It's not every week, every month, but certainly over the course of a year, there's certainly work to be done. So we have to make sure that we're keeping these systems up to date, or when new incidents are happening or new safety alerts happen, those need dropped in as well. So there's quite a lot of data sources, and therefore there's quite a lot of work that needs done to keep these up to date.
Thank you. So I have plenty of questions from myself, but in case Rafael, you want to ask a few, or Jovan, if you want to also ask David a few questions, please go ahead. And otherwise, I'll go ahead, but feel free. Just get started if you want.
I had one question for you, David. You mentioned at the end of your presentation that there were some areas of well integrity on which AI was definitely helpful, and other areas on which it was more difficult to get added value. Could you give examples or a glimpse of which type of questions or scopes AI can satisfactorily respond to in well integrity?
Yeah, so, well, maybe to answer, there's places where it doesn't do so well, where there's a lot less data, inconsistent data. Certainly a lot of smaller operators, for example, just might not have the data accumulated from, their small well stock to actually understand these things. If you're looking for the major failures, a lot of that, a lot of companies have got very, very small data sets on that, and any other data sets aren't public. But where you do have, lots of data, where you do have clear governance on which to draw upon, because that's really, incredibly simplistically, but that pattern recognition is what these things are doing. So it's very easy to compare two things. So if you've got sufficient examples of what the right answer is, then that's absolutely one. But on to the monitoring and forecasting, although we directly haven't done very much in that space, there is a lot of hugely exciting. So where you have lots of inspection data or sensor data, and you absolutely can develop rule sets that if the following is true, then this is something that needs flagged. That's really, really good as well. And maybe just the final thing on, just because that data might exist, is again whether you can access that or not. A lot of data exists, but it might be buried in hundreds of pages long inspection reports and things like that. So actually a lot of work needs done to get that data into a usable format. So actually, although we've made lots of AI products, it's hugely exciting. We've spent an enormous amount of time basically doing data science and coming up with new tools to extract data and things like that. They've got nothing to do with AI. So, the data, when I first started to work in it, I thought all these people talking about the quality of data, that's not going to be a big deal, right? But it absolutely is. So, but yeah, loads of exciting examples. But what I'd say as well is, don't just take my word for it. I'd say, start working on really small pilot projects internally, and you'll soon learn whether there's something here or not.
Thank you, David.
Similar questions from my side. So we are basically driven by data within the AI, and I will focus on those, let's say, environments which are probably unique for the field. How AI can help us, or we are still driven by data, and we need to assess the well. We need to invest a little bit in to extract the data from the well, meaning on multi-finger caliper log, corrosion logs, or behavior in the annually, to be able to have a decent work behind for the AI.
Yeah, and you're absolutely right. And that's why I always say, start small, get a pilot project, something that that there is data there or not a lot of work required, demonstrate to the relevant stakeholders that this can be done, and then prove that. And so much of the work that we've done or been involved in started off with a ridiculously small pilot project where we didn't do very much at all, and that got enough stakeholder buy-in to then go, okay, it is worth us investing some time and money in updating how this data is captured so that it can then be used. So absolutely, there's a bit of, you don't have the cart before the horse, but you need to maybe, as a bit chicken and egg, do you sort out your data before you've proven there's any value in doing so, type thing. So I think a lot of people are struggling with that part.
Thank you, David. Back to you, P.
Very good. So on the you've talked about the rules. You had an example of how AI can be used to help with corrosion defect detection. So for this, can you elaborate a little bit? Because for me, it is one of the things that the industry doesn't do very well, generally speaking, is to predict corrosion in water injectors. So we keep losing water injectors. And so can you explain how your work allowed for better prediction? Because you certainly needed real data acquired on at least a few wells, or data on failures, and then you probably needed an updated or fairly well calibrated corrosion model. So can you elaborate a little bit on that?
Yeah, so just maybe one thing, I'd love to say that was me, but that was a sort of just project that we are aware of, and I think it's an IPTC paper on that. So basically they had the electromagnetic inspection data, and they essentially, I must say I didn't fully understand exactly the next sort of step, but they essentially used that to infer like defects in the casing or the depth of the casing, and then that highlighted to engineers to then do further analysis, do further work. So again, that seemed an area that did seem to work out really well. I've seen a lot of work with images or readings like that. So that's really, really, really interesting. But I suppose it's those two things that I was talking about, where there's lots of in the field live data work going on. And I think there's lots of other companies that have seemed like they're really well ahead there. And then I'm probably a lot more interested in there's actually a lot of issues that we cause ourselves with poor decisions made back in offices. So I'm more about trying to, I don't know if quality checks necessarily the right word, but help us to improve and be more consistent and more focused on the right things there. So yeah, that's an IPTC paper, really, really interesting there, interpreting some electromagnetic thickness measurements on the casing strings, and they were definitely picking up things like wall loss or pitting that, you know, a manual review when you're having to look through dozens and dozens of photos or the charts you might not pick up. So that was a really interesting one. I'll find the link to it and I can share it.
Yeah, if you want to share the reference of the paper, it would be good. So faced with a dilemma to start a project like this, embark on a project like this, for an operator with a sufficient library of RAs, old RAs, and faced with that specific challenge, would you start afresh and start structuring the RAs today and then build a data set on them? Or would you also start looking at the old set of RAs and try to see if you could filter, get some of them that would be really too old, unusable, and what's the percentage of those in a historical library do you think could be used for getting your data set started?
So I'm in two minds about this. When I first started this particular project, I thought, this is amazing. There's so many of these. This will be so easy because every failure that's ever going to happen will have happened at some point. So they'll have past context of that we can use probably multiple times. This is awesome. But actually, when you really break it down, you go, well, what are we building? Are we building almost like a predictive text machine where we're just going to like predict what's going to go in the risk assessment based only on past risk assessments? You go, well, okay, but we already know that there's problems with them. That's why someone's asked for something to be done. And you go, well, is that what we're trying to do? No, we're trying to form a risk assessment that thoroughly assesses the current risk, any related risks, and develop a forward plan so that we reduce risk to alarp. So then you go, well, why do you need past risk assessments here at all? Surely it's about just an individual risk assessment being checked against all this different criteria. So I don't think you need as much past data to do a lot of the review stuff as you think that you do. Don't get me wrong, the past risk assessments were beneficial for maybe how we constructed our questions and the examples that we gave, so it's in a format that they're used to, and there was some valuable things in there. But I think clear governance criteria to compare to is way more important than past risk assessments. So I don't think a smaller operator should feel that they can't do this because they don't have thousands of past risk assessments. It does help, but actually, if you're going to use AI for something and you've got clear guidance or criteria that you'd like to check on, that for me, getting that stuff more clearly defined is actually far more valuable. And yeah, I think if you had a product that only took the blended average of all the relevant risk assessments and a product that compared your risk assessment to governance and gave you pointers, I think that second product would be far more valuable. So it's maybe a slightly long-winded answer, but yeah.
Yeah, and one reason I'm asking is because I've felt that tension between, two different beliefs. One would be that AI is going to be so advanced that it will extract information from the old risk assessments anyway, and it will understand everything, etc. So we don't need to structure the data. Or you start thinking, okay, well, maybe we should structure the data a bit today and maybe get to faster results, and it's a healthy thing to do anyway.
So I do think that's a good point, and I do think there'll be some companies that will almost miss out on getting the full benefit of tech such as AI because they just don't have systems in place. But an easy correction today would actually really help them with that. So absolutely, people will miss out. Just on the point you said there, it's really, it's very humbling. You think you're good at something, and then you find out that you can just ask the latest model of ChatGPT, and it actually knows just as much as you. I think we've all suffered that at some point, going, am I as useful as I thought I was? And obviously, as more of the internet gets trawled into these models, you could probably, without any work from a company like us, just describe a well integrity impairment and ask it what you should do. And I would imagine that a lot of the results will be really impressive, But as I've said, there's two sort of things, there's two problems with that. And one is that there's the sort of the black box nature of this. If you can't explain how it's working, then it almost doesn't matter if it's right or wrong. And then the second one is, well, none of us know exactly how these models are pulling all that information. So if there's a particular type of impairment where there's lots of info on, it might do very well. But if there's one that there's not, then it might not do so much. So you can't really tell if it's going to, how consistent, how good it's going to be. So we do lots of stuff where we might break a big task down into like 20 subtasks. A lot of the time that might not be required, but I know it'll perform for everything. And I know I can show what's been done there. So yeah, I think models are really tremendously impressive, but we're not using AI to write social media posts here. This is really serious work that we're doing. So we have to make sure that every step of the way we can show that we know exactly what's happening.
And we've had a question come from Michael Damer, who's asking, do regulatory bodies accept RA developed by AI?
So it seems to me that there's the short answer is it depends. I think, so if you're an operator in the UK, there's stuff on their website, really good documents. Actually, it's quite clear what their position is. As I've said, there's the EU AI. I think there's a varying one. So that really goes back to knowing your governance. What will the regulator accept? I think it may be an interesting point for me. We've got lots of stuff in production, and I'm not aware of the regulator ever having looked at anything.
Yeah, so I'll venture some info gathered from conversations around the world with through SPE and different regulators. So I think this is not likely to happen soon, and regulators will still want individuals to sign off because you have the legal aspect of owning the responsibility and the risk taking, and so the governance becomes an essential part. It might happen in the future, but at the moment probably not, and for the right reasons.
Yeah, I would. So from my experience, it's quite limited in speaking to regulators on the subject. I've struggled to get a meeting with the UK HSE on this subject, but I think it will vary. But yeah, the law still applies. So if you can demonstrate that you're meeting the law, that you're satisfying good practice, etc., then I don't see how they can object. I think the issue a lot of people will have is that they'll have an AI solution that they think is performing well, but then they realize that for various reasons, one might be that black box nature. They can't demonstrate how it's working, therefore they can't demonstrate compliance. So I'd say the more advanced, the more autonomous the solution that you're working on, I think the earlier you should engage the regulator. If you take everyone, for example, humans still do the risk assessment. Competent people, competent experienced people still sign it off. All we're adding is an extra layer where the AI is almost coming in like a smart know-it-all engineer and just saying, hey guys, you've maybe missed this, this, and this,
Questioning.
For me, I don't see how the regulator can challenge that. But
yeah.
But what the regulator might do though, is they might challenge, well, could that be misused? What if the working practice develops where we just say yes to all in the AI? And then the reviewer doesn't even read it, So this is why I've been keen to speak to the regulators. They might have an opinion on, well, we're actually happy with the system as designed, but could this be misused? That's what they might be concerned about, and that for me is not fully been tested. Yeah. Good.
So I think we're going to conclude, fairly quickly because we've been at it for a while. There's one area where I also see potential. I don't know if your current client or if you see potential also, is to help structure the RA so that the outputs can be easily used further down the line by software like Synergy, for instance. So the MOC tools know exactly what barriers are in place. They have the date, they have an owner, etc., as you have mentioned. So is this something you've been working on for Neonext?
Yeah, this is something we've worked on quite a lot. Like So, when I first started building software long before AI came along, I was told that the most useful feature you'll ever have is the export to Microsoft Excel button. And it's so true, no matter how good your software is, something else gets done after, So, and our software for NeoNext is no different from other things, as the ability to connect to other systems. So, for example, they've got their various they're really sophisticated on the dashboard front. So we've had to make sure that we can talk to their dashboards and things like that. But that would be no different from other clients we've got where, tools like Synergy and all of that kind of thing, where you have to make sure that the data can talk, or that the output can talk to that. It's usually not that bad. Use of APIs and stuff's a lot easier than it used to be. But yeah, that's the other one is, okay, you've got your output. What do you do now? And a lot of risk assessment is really about communication, the visibility of that risk. So if we've got the world's best system, but it's an island that no one can reach, or no other data can get in or out of, we have, that's kind of defeats the purpose. So we have to make sure that then the output of our stuff makes its way to the right place,
Yeah, and one reason this is likely to grow in terms of need and criticality in some areas of the world is, I think, because we'll probably have to live with more and more deviations. So it's not like it's going to be temporary management of change and then a well will be returned to its nominal condition. It's rather that we're going to live with a specific condition, a degradation, and then another degradation will happen, and then another degradation will happen, and we'll keep piling these deviations that we kind of feel we can live with, but it's likely that this temporary management of change may last for a while. So that's where keeping track of the controls is essential.
Yeah, and that's a huge thing in the UK offshore industry, across the whole industry, is, these things been open for too long and problems that, we could live with, but we're not demonstrating it. It's not being closed fast enough, or we've become normalized just to living with these things. And part of it is just that we're drowning in stuff to risk assess, and it's just getting to that like backlog of like work. So, every industry is facing pinch points of like skills gaps or late life. I feel like everyone's having to do more with less. So it's almost the perfect time for some of these tools, if used in the right way, to come along, and they could really help people.
Yep. And finally, a question from Manish Srivastava, fellow WITS officer. Do you think we can leverage on the data to predict barrier failure?
Absolutely. So it's like, again, you have to have the info. I remember 100 years ago, I had a student placement for this aerospace company, and long before AI, and someone looked at every single big failure that they'd ever had and trended those like thousands of sensors and made all these patterns. And then once a week ran this thing, it took like 2 days to like run. Maybe tech wasn't quite as good back then. And any engine that showed any sort of pattern match with all of this would then get flagged, and somebody would start to have a look, and they were using that to catch early signs of these problems developing. And all AI does, you can just do that on steroids. So absolutely, if you've got a particular, like a array of sensors or measurements that you think might be indicative of the early signs of an issue, well, isn't that fantastic? Because then I used to be an engineering technical authority, and what I thought the job would be is I would almost be standing at the bottom of a waterfall with a bucket, and all the stuff coming down is all this info, and I can just take the info and do it. But I had to hunt for this info. It took me ages. So now if we've got all of this, things flagging to a technical authority, by the way, we think there's something here, maybe you should spend some time having a look at this. that's fantastic. So there's loads of ways, and it's really exciting.
Very good. Rafael, Jovan, any final comments before we conclude the event? Any applicability, future, any enthusiasm, or?
Yeah, for sure, this is a great feature which we have AI, and just to shape it how we want it and where to work for us. This is amazing thing which we still, there is a part which we didn't explore and how we can use it in the best way. But this is why we have David to put the forces and in the right place and to unlock. We as an engineer, we like challenges, and I'm sure that we will dig in the direction where we need to work with the AI and what we need to from the AI. So great initiative, David. Great job. Just wanted to also say that it will we will as a SP, which we will support this enthusiasm, and we will try to join together with community as much as information and wishes we have from operators. This is how we are driving our industry in focusing on the areas what they need and what we need to develop. So David, thanks a lot. Rafael, thanks for joining us. Pete, thanks for making this happen, and yeah, thanks for amazing presentation, David.
Thanks for having me, and thanks for the questions. Thanks.
Rafael, do you see applicability in various companies?
Well, obviously I have so much more questions. I will not destroy the timing. As was said before, I think we are only discovering the opportunities, and also sometimes in a much more tough way, the failure modes and the risks associated with the use of AI in our operational context. So I think it's one more ocean where we have to discover use cases, where we have to also upgrade our mentality, because sometimes the use we make of AI is a prisoner of underlying assumptions. Typically, we are used to ask LLMs to work for us as secretaries, but when inverting the relationship between the human and LLMs or predictive tools or conversational agents, we may also benefit from it coaching us, and helping us as a teacher, as a master that can guide us, maybe suggested before by yourself, Pierre-Edouard, through the different stages of a risk assessment, to guide us sometimes in the labyrinth of the amount of data we have aggregated over the last sometimes 50, 90, or for some 100 years, and tell us, you were able this week to review 5 risk assessments, but this weekend, as an AI intelligent agent, I was able to review 9,000 over the last 100 years. And have you considered this possible failure mechanism? Have you considered this or that? So I think, inverting the relationship between ourselves as human and AI for well integrity can be interesting, meaning no longer using this tool as a slave, as a secretary, or as a clerk, but also potentially as a guide in a forest of sometimes very, very dense data accumulated over time.
Very good. All right. So thank you all for the great presentation today, David, and discussion with the panel, sharing your expertise and insights with us today. Thank you to the audience for questions and active participation. The program is copyrighted by the Society of Petroleum Engineers 2026. Have a great day. You may now disconnect. So not for the panel, guys. I'll play the outro. Thank you.
People ask me why they should join SPE, and what I tell them is that SPE is absolutely essential. Frankly, if SPE didn't exist, somebody would have to go out and create it. When you graduate with a technical degree, a petroleum engineering degree, or other engineering degree, you get a lot of really good knowledge that gets you started on your career, and you learn a lot on the job. But the jobs that we have in this industry, they're really quite difficult. And you've got to have other resources, either to solve specific problems you might be having at the moment, or to better understand how to solve, daily issues that you work on. SBE provides opportunities to learn about new things that people are working on. There are great articles in JPT Magazine and the other magazines that we have that are really useful. If you're not reading JPT every month, I tell you it's essential to do that to keep up with the technology. We have excellent conferences where you can learn from people who have solved very difficult problems in our industry. And doing that is just incredibly important and incredibly useful. To me, I don't see how you can be an engineer working in the petroleum industry and not find value in the resources and the opportunities that SBE provides. It's an opportunity to meet people who can help you in the industry, and it's an opportunity to get the knowledge you need to be successful.